Hello, you are welcome to the second part of the lesson. So now we are completely done with the modeling. So now I have to load it. So come to general, you are on general. You can see this is general. This is general tab. Then you come to load and definition. Then come to load cases details. Then click on add. Then I'm going to add a load called dead load. Actually, I'm going to analyze this with the self weight alone, because the more you have the load, the more it's going to take longer to analyze. But in our next video to come, I'm going to show you the different loads, how you can add the floor load and all stuff. So I'm only going to analyze this building with the dead load. So dead load, and then click on add. So you close. So right now I've just defined the name of the load, which is dead load, but I've not added any load under the dead load. So let me add some load under the dead load. So I'm going to add just this one, the self load, which is the self weight. So the self weight is a dead load, so I want to factor it with 1.4. So you can add 1.4 here, and then you click on add, then you close. So automatically it will calculate the self weight on its own. You know, the self weight has to do with the unit weight of the material, whether you're using concrete or you are using the steel, then multiply by the thickness, by cross section. All right. So since you've added the thickness, you've added the section size, and then it knows it is a concrete, it definitely understands how it's going to calculate the self weight. So you don't need to define this is the value for the self weight. No. So right now I'm going to click on the self weight that I've defined. Then I'm going to apply it to a particular element that I want the self weight to be applied to. But right now all the elements here needs a dead load. So I want to add to everything, just use this assignment method, which is what assign to view. Then click on assign, then yes. So it's definitely going to assign to everything when you use the assign to view assignment method. So let's wait for it to do that. And then for the load factor that I added, that I factored in 1.4, is because that's the way I just want the self weight to be. You can decide to factor yours by 1.5, and you can leave it in 1. You know, that means you are not factoring at all. You just want the actual load to be used to do the analysis. But when you factor it by 1.4, you are definitely increasing it so that you can have a more critical way. Alright, so the load has been applied to all the elements, the beam, the slab, everything. Okay, so you can go ahead to add more load, but no, I'm not doing that for this particular building. So when you are done doing that, you come to analysis and print. Then you can just use this no print and then click on add, then you close. So when you do that, you are going to see the tab here, something like this. So after doing that, come to analyze, then click on run analysis, then it will analyze it. So if there's any error in the model, it will notify us. If there's no error, it will go ahead with the analysis. So there's no error right now, it is analyzing. So let's wait for the result. Had it been I have more loads, it's going to take longer. So but doesn't matter. You can decide to add your loads, then you leave it to analyze. Even if it takes about 3-4 hours, you can leave it to analyze. But this building is very large. You have about 21 stories, you have several beams, several columns, several slabs. So adding too much of load will take forever to analyze. So that's why I just use the dead load to analyze it for the purpose of this lesson. Okay, so now we are done with the analysis. So you can click on this to go to the post processing so that we can see what's going on. So okay, you can close this tab, and then close this tab, then maximize this. All right, so let's move forward to say the shear force. I see. So this is the shear force diagram. This is the shear force diagram. Alright, so this is how the shear force diagram looks like. So to see it more vividly, just hold on your control, then you zoom in. Hold on control, then you zoom in. So it will be very difficult for you to see it more properly. So but in this case, what you can just do is, if that's the case, what you can just do is just select on a particular beam. Just select a particular beam, and then you see the result of that particular beam. Let's say this beam, double click on that beam. Alright, so when you double click on that beam, you're going to see the general, which is the dimension and everything. This is the property, we are not so concerned about that. The loading, we use the dead load alone. Then come to shear bending. So if you want to see the shear force, come to shear. Alright, so it's going to draw the shear force diagram of that beam. So you can see we have it is a simply supported beam, because you can see there's a column here and there's a column here. So it is simply supported. So this is the column here at this point, this is the column at this point. Alright, and then the length is what is the length? You can see the geometry, you can see it is 4.2 meter. So you can see at this point you have 9.36 kilonewton, and here you have 9.24 kilonewton. At this point where you have 0, the distance is 2.1. okay, so that's just it. The total length is what's the total length? The total length is 4.2. This is approximately 4.2. So definitely at the center you should have 0. You should have your shear force equals to 0, and the center of 4.2 is 2.1. So that's why you are seeing this 2.1 here. So if you want to check the bending as well, you can click on the bending. So it's going to show you the bending moment diagram, the bending in the Y. This is the bending in the Y-axis. This is the bending in the Z-axis. The bending moment diagram. All right. So this is the shear in the Z-axis. That's 0 throughout. So you can see 0, 0. So if you want to check the deflection as well, you can see this is how the deflection looks like. So that is better than saying you want to see everything at once by clicking the, let's say, the shear force diagram, and it's going to draw the shear force diagram of everything, and that will be very rough for you to even interpret. So why don't you just click on a particular beam and check the results? Just click on some beams that you think they are critical, maybe some beams at the top and then the beams at the last level. So let's see the results. Come to results, then click on view value, beam results, then shear. Let me see the shear at the end support. You can see it has added the value, and now it is very dark. You can see. So this is not visible for whosoever wants to check the analysis results. You cannot see anything. Regardless of how much you zoom in. So let's just close that. So that's why I advise you to check it. You can just zoom in to see a particular beam. Let's see this beam, double click, and then you come here to check your result this way. So that's better. All right, so now we are done with the analysis. So that is how you go about the analysis. So in the next video we will continue with the design, and there are different ways you can design with Staad Pro. You can design with this tab. You go back to modeling, then you come here, design. Then since we are doing concrete design, you come here, concrete design, and then you go ahead to design it this way. But this is not how I want to design for this particular building. All right, so you can design here. You design here. So that's one tab. Another tab is you come to concrete design. That's what we call RC designer. So this is RC designer. You can see it will transfer you to a particular module. So you can see Staad Pro RC designer. So this is another module for designing. This is a completely different module for designing. So this is RC designer. All right, if you check here, you see that it has even opened a new tab for me. This is the Staad Pro, which is the normal Staad Pro, and this is now the RC designer. It is installed together with the Staad Pro whenever you install your Staad Pro. So this is another way of designing, and there's another way of designing apart from the Staad designer and the RC designer. The Staad RCDC and the advanced concrete design. So we'll be using the Staad RCDC to do the design. So just watch out for that as well. Thank you.